I think everybody agrees that we have too much data. And it's only a good thing if you sell storage for a living. Other than that, it's something of a problem. And I'm not just referring to the business-oriented data. So clearly the things that power social media, financial systems, scientific research, operational systems, clearly we have a lot of data there, and it's increasing in cardinality. I'm going to talk a little bit about why that is and what we can do about it. But also all the operational data from a systems administration perspective. So data about how that business data is generated, transported, massaged, delivered, managed, secured, and otherwise accessed is also growing, I would say exponentially. And I tend not to make a distinction between those two buckets of data. And you'll see I kind of bounce back and forth between data that runs the business and data that we look at to find out about the business. Because I think that the operational view completely and totally colors what we do with the business data. And as I get toward the end of the talk, I think you'll see that a lot of this comes down to how we define what the user experience is that we want, how we want to color it, how we want to deliver it, how we want to measure it, and what can make it go into the weeds. So let me start kind of with the first question is there really such a thing as too much data? And I was at a talk in Israel about 3 months ago, and Kevin Tabb, who's the CEO of Beth Israel Deaconess Hospital, got up on stage and essentially said, just stop already with the data. I have too much. The problem is I have no idea what to do with it. And he went on to say that the issue is that he's being asked to solve problems, and he doesn't really know what the questions are that relate to the problems. People just keep throwing data at him saying, look at all these pretty correlations we found. And I think the problem underlying this is if you array all your data on the table and say, ooh, let's go find the cool patterns, it turns into a website where you can find interesting correlations between things that have absolutely nothing to do with each other. There is no causality implied in it. So the issue here is, how do we make sense of the data we have in a way that allows us to go determine what the patterns and the paths of causality are? Otherwise, we just toss everything on the table. We're not just looking for needles in haystacks. There's this International Harvester Combine dumping more hay in the back of the room while we're paying attention, necessarily making the problem larger, and we aren't really sure what we're looking for. And I think that part of this challenge arises from the fact that as computer scientists, we like to put data in the middle, because it's something that we can go point to. You can go count the disks in the data center. You can go look at it. You can go see how many Amazon instances you're running. And it's something it's very, very concrete. But if you start with the view that data is in the middle, I think you lose track of the fact that actually the other two lobes, and this is a requirement if you want to give a talk, you have to have a Venn diagram. You have to talk about Venn diagrams in comics. The comics are coming. But part of the challenge here is you say, well, if I have all my data, look, it's really good, we can go find patterns in it, isn't that useful? And that's the computer science or the data science view of it, which is, well, if we take a look at this data and decide we're going to go apply machine learning to it, or we're going to go do statistical reduction on it, we're going to go apply a series of mathematical models to it, look at all the great results that come out of it. And again, that's the computer scientist looking through the lens of running and scalable code into the data. And I tend not to distinguish between computer scientists and data scientists. Data scientists, to me, are just the children or grandchildren of APL programmers who, don't know how to spell APL, so they talk about R instead. It's gotten easier to spell the tools of the trade. But again, same problem here. What are we actually trying to do? And the question is, what does the business really want to find out? What is it that they know or don't know? And I think the challenge here is, if I was to draw the Venn diagram properly, business is somewhere off the screen over, to your right, up in the corner there, because a lot of times they don't really know what technology and what the data can inform them about. That is, what are the breadth of the questions? What are the depth of the questions? What are the big, hairy, scary, audacious things that should be asked? So the challenge is to go from business perspective, what is it we really want to go do? What behaviors do we wish to go change? How do I ask the questions of the people who know how to go translate interesting thought into running code, and then apply that to the data to go figure out, again, what does the data show us in terms of correlation or causation, and eventually then come back and drive some value back up to the business. At the end of the day, the intersection of business to data is all about behavior change. We want people to do something differently. It could be that we want you to buy more of our product. It could be that we want you to consume more of our service. It could be that I don't want you to do certain things. It could be that, again, I will not make the differentiation between what you do as a systems administrator and what you do as someone who runs a line of business. I want you to be, a little bit more focused about how you use resources. I want us to be a little bit more focused about how we think about security. Those are all behavioral changes. And again, the data provides us some lens underneath it, but it really is about figuring out what the right and appropriate questions are. So let me give you 4 views into how we deal with this problem. And I'm going to start with thinking about how we categorize our data and essentially prune it to find the most interesting parts, and then how we go about thinking about that problem of behavioral change once we've identified the appropriate set or subsets of the data. So you think about this, the first thing is I always like to apply supply chain thinking to things. And part of this comes from having worked with a lot of companies in the manufacturing space. And at its heart, a lot of the things that Merck Co does is about manufacturing pharmaceutical products. So where is the data coming from? How do we draw its graph of its supply chain? And how do we look at things like its provenance and the rules for how we propagate it along the different paths of that supply chain? And the second part of that then is to actually start to filter it or summarize it or otherwise thin it down. I'm not saying that we should have less data in general. I think that keeping things, by nature I'm a pack rat, I keep way too much stuff. It makes moving an adventure. But in general, you never want to get rid of data. The question is, how do you find just the right amounts of it to use at any one time? And that's essentially where we go from an easy problem of a lot of storage to a hard problem of figuring out exactly what the data sets are that are going to underlie a particular analysis. I want to talk a little bit about things that we've seen that have happened in the entertainment business. I think that shine a great light on what we can then go do in terms of other behavioral approaches, particularly by assigning genres to data and thinking about how we might better filter or aggregate it. From there, I want to sort of shift a little bit and use that lens into the data to think about what does good mean? Because again, at the end of the day, what we're trying to do is define a good outcome. And I want to define the definition of good through the lens of looking at failures, and in particular failures over time. So as we start to correlate what's a missed outcome or a bad expectation or a bad user experience, and I translate that back into, well, something failed, what was that? And again, how will I trace it back through my data to figure out what exactly was it that failed? And again, at the end of the day, I'm going to go change someone's behavior. I want them to go do some things differently. And if I think about this again, sort of in 2 halves, the first, the supply chain and genre identification is really about identifying patterns and trends. It's a filtering problem. And the second one is about actually doing something with it. And this goes back to the point that Dr. Tab made. It's not just that we have a lot of data and we're buried in it, it's actually make it actionable. Come up with something that makes sense, and not just a specious correlation where you happen to find data sets that look really cool together, but actually show you where you can go and get people to do things differently. Either through inference, because you imply that there's a better way, or you give them a better user experience, or in some cases through explicit change. This is a chart, I both love and hate this picture. Because in one view, it tells you why my job is interesting right now. And the other one, it's anything that says Rebel Alliance that was published in 2014 is like 3 decades out of phase with at least current nerd culture. I keep expecting Admiral Akbar to pop up at the bottom and go, it's a trap, there's too much data here. This is a chart that came out, there's a blog called Health 2.0 that looks at what's happening in electronic medical records and the intersection of our personal healthcare devices and electronic medical records. And they drew this really great landscape of all the different sources of data we have and all the different ways that they're being consumed. And so I said, wasn't that great? Here's a map of where we're going to go with our data. I looked at it and said, this is actually horrible. Because it's a landscape. Again, someone took the deck of cards and spread them all out on the table and said, ooh, great, let's go play poker. Here are all the cards. And it doesn't tell you anything about what are the different sources of data in terms of their value or their validity or their trust or even their medical necessity. If you have a Fitbit or a Withings, I'm on my 4th one. So I have my little step counter here. Interesting, but this is not a medical device. This is not an FDA-approved device. It's not because it's not giving you information that is medically necessary. It's cool. It gives you data, and the data is mostly accurate, although, again, there's certain activities it doesn't really count really well. But it doesn't fit into this landscape in terms of thinking about things from a medical necessity or a quality perspective. The other thing is it doesn't tell us where the data is going. There's absolutely no picture here of what the sources and sinks are. If I were to go draw a network view of this world and tell you, here's where the data is being most produced, here's where it's being consumed, here's where it's being transported and modified along the way, it's impossible to tell from this. Again, it looks really cool because someone tried to do it very New Yorker magazine style cover illustration, but what comes out of this doesn't really make sense. And at the end of the day, if there are outputs here, I don't really know where they are, and I don't really know how to value them. But again, I hold this up because I think as you look across the lines of business, you will see pictures like this show up all the time where people, like I say, look how much data we have. Isn't it great how much data we have? Of course it is. It's wonderful we have all the data. But you know what? There's nothing actionable there. So what I'd like to do is take a different perspective on this and prove to you that if you like comics, you have a great IRA. And bear with me for a minute. We'll start with Richard Stevens, Diesel's Sweeties. Of course, if you saw that and you recognize his robot Klango dreaming of the electric sheep, the first thought is, I saw that on Big Bang Theory about 4 years ago. Will Wheaton showed up in the Wheaton recurrence wearing that shirt. You say, wait a minute, that's not about Will Wheaton. Next thought is, no, androids dreaming of electric sheep. No, it's Philip K. Dick. Matter of fact, that was the original source material for Blade Runner. And again, you can usually sort of tell the generational split now between people who saw the original Blade Runner and people who've seen the remake of it, and they argue about the ending at this point. So if you want to argue about the ending, we can do that later. So, well, no, Philip K. Dick, that was cool, but how about Scanner Darkly? That was actually a much more interesting, much more paranoid and mildly freaky book. Yeah, but the movie treatment of that was terrible. Where did they get the idea, A, to use Keanu Reeves, and B, to rotoscope him? Rotoscoping? You mean the Charles Schwab ads, Ask Chuck. You must have a great IRA. So I have now gone in 5 steps from modern webcomic to 6-year-old ad for asking Charles Schwab for investment advice for your IRA. Each one of those things is an interesting correlation. I can think about this in terms of the genre involved. So I'm thinking about, okay, I like comics. Where did I see this comic image before? I happen to like this actor. Where have I seen him or her before? I happen to like this book. What has been adaptations and treatments of that have turned into movies, and so on and so on. But to actually follow the graph all the way through and follow all 5 chains of it, that's an illogical conclusion. One has absolutely nothing to do with the other one. And I think that's the disillusionment, if there is any right now, we have by thinking about how much data we have, is that we find these individual pairwise correlations, but when we want to go put them together and sequence them, what comes out the other end doesn't really make sense. And I think that's the challenge here is it's great for us to use our data for deduction. Each of those stepwise things is fine. As a matter of fact, if you're at Amazon, if you're at Netflix, if you're trying to build a recommendation engine and you're looking for those points of intersection by author, by treatment, by style, by artistic style, by domain, those make perfectly good sense. But the larger challenge, of course, is to go build a graph and figure out, well, what does this mean from an induction perspective? That is, how can we actually go learn something about what it is we're trying to go change behavior-wise out of this? That is, where is there actually causation happening in this graph? And this is why I try to put the supply chain lens on. So the first part of this is realize that more and more everything we're dealing with is coming at us in a set of streams. Again, I think this is a case where the LISA audience, very, very large, has been living in this for at least the last 5 or 6 years, and the rest of the world is going to catch up. That we're not just dealing with large static data sets, we're dealing with data sets that are large and growing in time. And if I think about this in terms of the overall size of the data, clearly look at something like a high-def movie or HD radio, HD audio content, you're talking about gigabytes per hour, and your typical span of attention there is a few hours, in case of a movie. Now you look at something like your immobile environment, your home with Nest thermostats and your Internet of Things. So a Nest thermostat's going to throw off 10 or so measurements an hour. So if you're lucky and you have a lot of devices in your home, maybe you can do a megabyte per hour out of all the devices in your home. So again, over the course of a day, audio and video dwarf the home, but in terms of the actual time period involved, you're looking at your home now over at least a season, if not over the course of a year. Now I take that to my car, I get a lot more data points out of something like a Tesla. Typically, again, over a shorter period of time, I may look at my driving patterns, I may look at my efficiency, I may look at anything else, again, over a period, maybe over the lifetime that I own the car, so over a period of years. And finally, when I take something like, again, like my fitness tracker, there I'm getting, 7, 8, 10 measurements off of it. Maybe you get 10K off of your Fitbit every day. But I now want to go take that over the course of a lifetime or several lifetimes. On one hand, I look at it and say it's really not that much data. You're really looking at about, for most diagnostic tests, 2K a year. Even if you're a hypochondriac, 10K a year is a lot of data. But now I multiply that over how many days, over now decades of data collection. There's quite a lot of data there. And it was great. It was actually cool to hear Gene Kim this morning talk about Rob Kolstad inviting him. So I remember Rob Kolstad had actually remarked a long time ago that being in systems administration is one of the very, very few disciplines where the timelines you're dealing with range from nanoseconds to thousands of seconds. And I think now as you look at this, again, in things that go from hours to lifetimes, and the volume of data going from few kbytes up into gigabytes, as you start to multiply it out, we find out, as I think that for any stream that we're looking at, the overall volume of data is probably going to be the same over the lifetime of that stream. Just that the time over which we collect it is hugely variant. What does that mean? A, I really have to understand where the data is coming from and how much of I want to keep and how I'm going to keep it. And B, I really want to capture as much as I can about where and how the data was created, because I might not know that down the road, and it may actually be interesting. And this is one of those cases. So if I actually take, so the WithINX I have has the, it'll actually look at your pulse, and it can do some, some very simple, blood pressure mechanics on it. What if I happen to know that this is traveling 75 miles an hour between 7:30 and 8:30 in the morning, and because it's connected through my phone, I also happen to be listening to Norwegian death metal. Now, there's two options here. Number one is I am the reason why people in New Jersey can never drive to nice things, because I am the cause of most traffic congestion. Or I just happen to have a really particularly bad morning. Again, over a period of time, you'll find that out, and you'll actually figure out what that means. But that only becomes interesting when I take all the other contextual data about where the data points were generated. Where was it? Where was it in the network? How was it moving? What else was happening at the time? How does this line up over a long period of time with other sets of data points, where I can then start to, again, put a map together and say, this is what I know about where the data was generated in the network. So if I think about the issue of what streams I have as just discovering what the endpoints are, now I want to actually start looking at where they're generated and how am I actually going to start to do the collection. The second part of that is looking at how do I instrument where the data is transported to the point where I'm going to actually go and persist it. And Dave Ward, who was CTO for systems at Juniper, is now CTO for hardware systems over at Cisco, likes to talk about the difference in perspective you get being on the network versus in the network. If you're on the network, you're sort of looking at everything else as your peer. And whether you're doing data collection, you're doing instrumentation, you're running another app, basically the network is just this transport layer that you assume. If you're actually in the network and you think about what is possible in this world of software-defined networking, as we begin to add code that runs essentially below the level of TCP/IP, that's able to observe what's happening at a transport level, we're able to pick up many, many more contextual clues. So problem A here is I'm generating a lot more data. It's not just about where things are generated, but I'm also picking up all the contextual data about where did it come from, at what time, what else was happening, how did it get here, what may have been happening along the way in terms of congestion or latency or other events, and I'm going to then go and persist it. Again, the challenge in persistence is what I start out with. It's not just the data we have that's driving the business, it's also all the data we're generating along the way about the systems that are operating. So it's our security data, our log data, everything we happen to know that's coming off of data coming off of the routers, switches, and firewalls as data as well. And while I'm quoting old science fiction authors, Robert Heinlein likes to say that every generation believes that it invented sex. I also think that every generation of system administrators reinvents syslog. We consistently feel the need to go back and figure out how we're going to go parse logs. And again, you see this every time you see something that shows up with the letters NG in it. There's your existence proof that in fact we do have this generational view of how we're going to go and digest all of our log data. So let me take another step forward on this. And part of the challenge in figuring out how to go thin the data is not just to do it from an operational perspective, but also to think about this in terms of the domain of use or the field of use of the data itself. IBM likes to throw out the 4 V's of data in terms of its value, its veracity, its volume, its velocity. Basically, where is it? Do you trust it? Where is it going? How much of it do you have? And how quickly is it growing? I will never resist the opportunity to make a semaphore joke. I like to think about the 3 P's of data. It's provenance, it's privacy, and it's propagation. And this is, particularly in healthcare, this is a very big issue because we deal a lot with anonymized data sets. I'll get data that will indicate that an anonymized patient had a procedure done, and I want to be able to operate on that data. I have to be very, very careful where I use the data and what I do or do not commingle with the data. So you're talking about, oh, we could go do all these great joins, we could go and do a side join, we could go and look at other sorts of public data we have. You have to be very, very careful. Here's a goofy but illustrative example. So if I go and take an anonymized credit card purchase record, so I happen to go, let's say I go and I get my hockey skate sharpened across the street from the rink where I skate every Saturday. And then later on in the day, I go and tweet that I saw my friend Chad on the ice, a friend of mine who just recovered from fighting leukemia. That was really cool. Okay, what do I have here is based on the location where I was when I made the credit card purchase, because you happen to know what the retailer type was, the fact that it was a skate shop pretty much places it to one of about 15 or 20 businesses in New Jersey, particularly when I then go and show where I was when I made the comment. I can now start to narrow it down to about 3 of them. The fact of the matter is that with a little bit of cross-correlation here, you figure out that I was at that rink. The fact is that if you know me as consumer 123 through my anonymized credit card purchases, but you're able to join that data with this public stream that comes out of either Twitter or Facebook that gives you a hint of where I was and when, and there's enough contextual clues here. On the ice, again, neatly maps to hockey skate sharpening or anything else in a hockey shop. You're able to go back and say, you know what, with reasonable attention here, that's probably Hal Stern. If not Hal Stern, who else had their skate sharpened there that morning? And maybe you get down to 8 or 10 people. For purposes of anonymity, the FDA likes to say that 11 people is considered anonymous. That's the smallest cohort they still consider anonymous. I think over time we're going to find that we want to go much larger than that. That your anonymity really requires you to be part of a much larger group, that we're not able to uniquely identify you to 1 in 100 or 1 in 1,000. But it's a hard problem. And the problem stems from not being allowed to go join sources of data together. So that's the propagation aspect of this, is if I have a data set, where shouldn't I take it? Because combining with other sources of data will necessarily, possibly and accidentally, either narrow the cohort of potential identities or in some cases uniquely identify someone. And if you think about what we've been able to do with authentication models like OAuth, this notion of having a valet key that you can hand out for partial access to a website, I think that there will be similar models we'll be able to develop for partial access around parts of data or even parts of a data set where, again, we will mask or further de-identify or further hide things depending upon what we want to go join them to. And so this is where we get into the issues of provenance. How much do I know about the data? How old is it? Where did it come from? How certain am I that it is in fact correct? How clean is it? And again, where might it have been joined along the way or had other sets of data that essentially have a less clean provenance joined into it? And those things together actually give us a line of sight into privacy. I raise this not as a statement of, well, if we just had less data, we wouldn't have this problem. But the fact is that having so much data actually makes this worse and makes it something that will show up in places where you don't expect it. It's not just healthcare, it's not just financial services, but again, it is in almost anything where you're dealing with data where there is a requirement to preserve people's privacy, or at least a moral requirement to preserve people's privacy, coupled with the fact that there's an awful lot of public data out there that belies that privacy at the very same time. So where do we take this supply chain of data? If I go and build the graph, I go back and think about my sources of data that are transported, they're persisted, I'm now able to go look at them and figure out essentially how data flows through that system or how data flows representing what in fact may actually be causal elements of the system. Now I actually want to go and come up with less of it. And there's a number of interesting the standard view here is, okay, let's go apply tags, let's go do some filtering, let's go look, by things that we identify as system administrators, by IP address, by host name, by type of traffic. And the problem with that is I think that by doing that, we don't really figure out how things are related to each other at different points in that supply chain. And the two examples I use a lot of companies that do this very, very well are Netflix and Spotify. And both of them rely on being able to take a lot of descriptive data. In the case of Netflix, it's people's reviews and tags and genres that they then apply to the video content they have. In Spotify's case, and again, Spotify as well as your other favorite music recommendation service, essentially what they're doing is they're taking the digital music signal, running it through a series of fast Fourier transforms, and ascribing elements to it. Its loudness, its danceability, its beats per minute, how treble or bass heavy is it, what's it structurally like. And that's where you find out that it's not that hard mathematically to say, if you in fact like King Crimson's Larks, Tongues, and Aspic, 7/4, features sheet metal as percussion and a lot of dissonance in it, you will also love Animals as Leaders. Again, people who know King Crimson probably haven't heard of the other one, and vice versa. So what's really interesting is now you have people who essentially are 3 musical generations apart, able to discover each other's music because they happen to be related through the fast Fourier transform. And it's very easy for you to say, here's one, I'm going to go identify its key attributes, the things you like, and recommend other things to you. How do we do that for data that is not audio or video? And if you think about where do I want to start ascribing tags or descriptions or other ways of thinking about where I might annotate that supply chain, not just from a business perspective, but particularly from the operational perspective. And it could be anything from adding a note. You think about all the discussion that has happened up the first day and a half of the conference talking about postmortems and discussions of failures. As you go and ascribe those things to particular points in your data stream, you now have the ability to go back and apply either natural language processing or machine learning algorithms to it to start to figure out what's the genre of a failure. What's the genre of a particularly busy time? What's it look like? And again, what upstream systems are affected by that? Again, I toss it out there. It's one of the problems that in healthcare we're certainly very, very interested in right now, because we start to think about genres now in terms of stratification. How do I look at different groups of patients and how are they related? And they may be related in many, many different ways, not just because they happen to have the same diagnosis code or they happen to go to the same doctor. In a lot of cases, this allows us to look at a much broader section of the population. If you think of, replace patients there with users, replace it with consumers or customers, again, I think you have the opportunity here by assigning genres to figure out, where is it that you can actually start to find these related pockets or related streams that go through your data supply chain. At the same time, there has been I would say a reasonable amount of pushback on tagging and the use of tags. Cory Doctorow back in 2001 wrote a great piece that appeared on The Well. If you remember The Well at the time, that was actually a great place to go publish things, called Metacrap. And his comment at the time was, people lie, people don't do a good job, and people lose interest in it. So if you rely on everybody going and documenting or adding their semantic knowledge of things, you'll be sadly disappointed. And again, he wrote that sort of before Netflix became the dominant way that people discover a lot of the video content they discover. So I look at this and say, yeah, true, but if you take it as a given that doing so has value, ascribing tags, ascribing metadata, ascribing description of things has value, we can then start to apply some of these other genre selecting systems to go and look at our data and essentially pare it down to the things that are interesting. What I find truly amazing about Netflix is you went from thinking about the 6 or 7 genres of movies, action, horror, documentary, romantic comedy, cop film, to 16 or 20,000 genres right now. So you say, and I always tell people, think of coming of age movies set in the 50s, male protagonists. And people think for a while, they say, American Graffiti. Okay, great. How about Grease? How about Stand By Me? And of course, it turns into a whole other set of Will Wheaton jokes after that. But what they have allowed us to do is to think about parsing these things, again, in some cases that crossed generational differences of what constituted a movie of that flavor, and start to put them into equivalence classes. Now, the challenge with this is if I take my genres and take my streams and put them together, I actually have to get something usable out of it. So this is, you think of Fitbit or Withings or your Jawbone, up. This is what you say, okay, it's someone who's clearly interested in using this to go better track their health, their physical activity, and figure out, again, what's happening from a quantified self or at least from a better understanding of their own metabolism. And you think about this, all right, I can use this to go drive my weight, to go drive my diet, to really understand what's going on. The challenge, of course, is that it's also the guy on the right who has the Fitbit. And it's not that, that data is not valuable, it's just as valuable, particularly, again, as you think about where that patient fits in or where that consumer fits in. It's a different set of questions. The data is just as valuable. In some cases, there's more data there. But I'm probably going to go and join it with other things. For someone who's at a different point in their health life cycle, they're going to be thinking about, am I at risk for diabetes? How about my cardiovascular health? What kind of exercise can I do? So it's the same problem of looking at the data stream, assigning it some genres, figuring out what else is in the genre, then deciding how I want to go make recommendations on it. Just that the correlation of the data, the supply chain data, is radically different along the way. And so this leads to a question, which is, what exactly is the story we're trying to tell? And in particular, as I want to tell the story, what's the outcome I want to have out of it? What defines a good outcome? And what defines a bad outcome? So it's very, very tempting if you have a fitness tracker to say, I will have a donut for breakfast, and I will just walk an extra 3,000 steps today. And if you're 20, it kind of works. The math, the calories in, calories out works. If you're 50 and over 50 and have a variety of pre-diabetic conditions, the math doesn't hold up as well. So the question becomes, why is it that you decide to eat the donut in the morning? It's not because you knew you could walk extra steps over lunchtime. What was it? And as you look at this as a narrative, you say, you know what, the point at which you made essentially the bad health decision, that was a failure. That was a bad outcome. We didn't want you to do that. What we really wanted you to do was to eat healthier. Well, what was it? And I go back to that, I'm driving to work at 75 miles an hour early in the morning listening to Norwegian death metal. Why was that? Again, is it a unique thing? Is it instance one? Or is this a symptom of a larger set of patterns? And the fact is, I may be doing that after having had my donut in the morning because I simply don't like my job. And the better answer is incent me to change my behavior by offering me things, not how many more steps I can take or how many badges I get because I took 10,000 steps today, but instead find things that I will identify with that I see in my story. And looking at that requires you to think again about this stream of data, not just what I collected, how the user interpreted it, but also then what's going to happen downstream. And one thing I love to hold up to people, and again, we've done this, I would say, a lot thinking about systems reliability and network reliability, but we have not really done it thinking in much larger scale reliability, particularly where our customers or our customers' customers are involved, is to think about how we actually look at failures and what the causes of the failures are, and particularly how we find the data about the contributing forces to those failures. So this curve I borrowed from Tobias and Trinde. They have a very, very dense book called Applied Reliability. If you are looking for something, good use of $75, go pick it up. It is a lot of math. But one of the great points that Trinde makes in here is looking at how we should break down some of our classic notions of what failures are and how they occur. So we always love to talk about mean time between failures. I think it's part of the right up there with how many nines of availability we have. One of the metrics we use, I don't think has a whole lot of value. And the problem with thinking about mean time between failures, if I were to draw this is failures over a lifetime. So let's say I draw this for a disk. The disk has a 10,000 hour MTBF. What I'll see is a neat little bell curve, so there are very, very few failures early on. And as I start getting closer to the average time when the disk fails at 10,000 hours, you'll see a neat, bell curve, peak of the distribution right at 10,000 hours, because that is, of course, the M in MTBF. And then they tail off. Some of those disks will last 20,000 hours. Some of them will last 100 hours. And again, if I have a lot of them, the curve will get much tighter over time. But I'll draw again a neat little plot. You're going to say, well, that's where, what actually has a curve that looks like that? And it turns out there are a lot of things that look like that. First of all, people look like that. Infant mortality in the front, and then we age, we get older, and we necessarily log out at the end. There's a fail. That's the final failure, okay? You're done. Software looks like this. And part of thinking about DevOps is I want to take those failures off the front of the curve. If I'm measuring the failures in time for deployed systems, I want the beginning of the curve to be as flat as possible. Matter of fact, I really want the end of the curve to be as flat as possible too. But that's assuming that failures never occur. They will occur. So the challenge becomes, what do we do initially? What do we do with canary systems? What do we do in test to pull down the height of the front of the curve for our early failures? And again, what do we do to do a better job of monitoring, detecting, and understanding dependent systems to pull down the end of the curve? And it's not just, again, it's not just software, but it's anything else that has a user experience associated with it. So if you're talking about how people are using your website, how people are using your service, how people are filing expense reports, you can go and look at failures described very, very broadly, and then look at how do the failures occur over the time that the system's been running. That is, how do they occur over the lifetime of the system? And I will argue that you can then trace this back and figure out for those failures, where are the sources of data that tell me something about what the contributing factors were? Your supply chain comes out of that. Then I can start to go through, identify what the related causes and effects are, what the related sets of data are, and start to actually do some diagnostic and in some cases some archaeology to go figure this out. But the issue here is that if we simply think about everything as mean time between failure, or simply think about everything as how long a system ran and then it failed, you miss this. And you miss plotting your failures over time. I think it's a very useful exercise in a lot of cases to go think about this. Because I'll look at this again. We can look at this in healthcare and say, where did the failure occur? Did it, how early or how late in that patient's health cycle did it occur? And that will give us a sense of, well, what might we do differently? And the interesting thing we found out about this, this is some work that we did with a brand trust out of Chicago, was looking at how is it that people decide to deal with their own healthcare? How is it people decide to actually deal with this problem of failures, if you will, in maintaining their own health? And I will draw, not just because of the fact we always talk about health checks when talking about systems, I will draw a parallel to the art of systems administration. If anybody here has, end users who go around and say, hurrah, I was able to print today, I got an IP address, and they're jumping up and down with joy because things worked, please let me know where they are. You have definitely a very happy user base. Most people live in this completely neutral world, right? Which is things just work, they expect that they work, and they're effectively happy most of the time that they work. But there's this interesting psychological effect known as the peak end rule, which is, it basically explains why you're always so angry when you get off the phone with customer service, which is your memory of the event is colored by the emotions that you had at the end of it. So again, people are pissed off when printers don't work. They're never happy when they do work because essentially it's an expectation that you're there. So you think about this, what you see is you sort of start off neutral, something bad happens. Again, think failure in time. It immediately takes you into a negative territory, which is, okay, something bad happened, I have a bad memory of it. What am I going to do to go take corrective action? You slowly work your way back up to neutral, and then you begin to change behavior. And people are incented to change behavior because, again, they saw that there was an improvement there. So they're incented to do more things that allow them to continue down the path of improvement. And again, then something else bad happens. And as you see, the triggers along the way here can be anything. It can be you getting sick. It can be a friend getting sick. You have to take care of a parent who's sick. But you tend to bounce up and down on this spectrum of whether you're positive or neutral toward your healthcare over time. And again, I will argue that the same thing is true as we think about what it means to effect good hygiene and good healthcare in the practice of systems administration. It's never a linear curve there. Whenever we're talking about how we deal with failures, how we react to failures, and how we go and look at the behaviors we want to go change, there's a set of behaviors that we certainly can change. How we do resource allocation, how we do prioritization, how we set bounds on consumption, and how we actually go and explain why we need bounds on consumption, why do we need rate limiters, why do we need feature flagging. It's because we're actually going and we're dealing with this graph. And yes, people say, oh, I had a really bad experience there. This didn't work reliably. Okay, let's go figure out why. And by doing so, again, we're treating that as a failure of what we're able to go deliver. By mapping it over time, we can then figure out, let's go match what the emotions were. Let's go match what the end users experienced there. Treat those things as failures in UX. And then go through and again, figure out what the data is that's sitting underneath it. Even in terms of figuring out how we drive better trust between developers. Again, I love the Gene Kim's conversation this morning about getting the two camps much closer to each other. But there's an opportunity here for us to change the sorts of metrics that we have. And my favorite metric around data is you can have a lot of it, and if it never gets used, it's not really good data. And you think about this is I want to go from a data hoarding metric, which is how much do I have and look how much I produced and it's all secured and no one else can look at it, to a data publishing metric, which is it's great, people used it, it showed up, looking at its provenance and its propagation, this is a set of other systems that it informed. This is where it fits into our supply chain. Therefore, it's good data. We should not only have more of it, but we should keep it. And we should celebrate and actively work on systems that give us that sort of data because it actually is participating in or contributing to our end-to-end flow and our end-to-end inspection of what we're doing. If those are the sets of behaviors you can change, I'll kind of go back to where I started. If you overlay enough data on this without doing the filtering, without appropriately figuring out what the systems of causation are as opposed to interesting corollary, you do end up with weird results. And of course, it requires an XKCD cartoon to really capture that. You will see things that aren't there, left unchecked. And I think this is the this is both the ask and the challenge. Being a system administrator means we are living in the world of perpetual minor brokenness. Nothing's ever perfect. That's why we all have jobs. And that's actually a good thing. But the very nature of the job says that there will always be this temptation to look for correlation that's not there, to take the end around and looking at causation, and again, to hoard the data, figure out how to go collect it without necessarily taking the time to go figure out what the supply chain is or what the set of dependencies are. And I think that at the root of this, when we think about how much data we have and how we want to filter it, there's a set of moral, ethical, and functional uses of big data that are ripe for an awful lot of continued applied research, but B, also tell us an awful lot more about how we can further move the art forward. So I have like 3 minutes for questions. Again, I promise I have to get off the stage so Dave can do his next song and dance. And I'll be around I'm around till the end of the day today if you want to find me as well. Thank you.